live streaming right now. Cool. Alright, let me put those on. Alright, the world is your oyster.
Cool. Okay, so I'm trying to figure out my camera to be stable.
Too crazy. Okay, we could stay here with Stranger Ted. Remember, stranger danger and bad touch now.
Oh my god. Thick paint? Oh, thick paint's way better. Oh, no way. No way. What is hypercolor? Oh, it's super cool. What? Oh, that's kind of dumb. Whoa. Fuck. Having a cow. Fucking stinky black guy. Rainbow. Oh, it's just ridiculous. Why am I stuck? Why am I? What the fuck? So I'm confused. Is Tiltbrush still going? Like, where is it? I know it's tough with it. It's tough. Let me go upstairs. She had to deal with it. Sorry about that. It should take me a week.
Oh no, it's cool. Yeah, no, I was just watching you the entire time. Really,
On your
dude,
phone?
I can hear you. Yeah, I can hear you.
You can?
Yeah,
Like, how much?
like everything you say.
What?
Yeah, you're just like it's like, oh, that's kind of lame. Like that's not that cool. And then all of a sudden you're just like you did like the woods. I don't know why you wrote the woods, but yeah, I remember what I said. So did it crash?
Yeah, something like that. Like the menu came up and I came up to it.
Oh, weird. Yeah, so for some reason, I don't know. I have to go in here and I have to the VR dashboard.exe. Like, I really have to reconfigure my computer setup because I'm not even running a genuine copy of Windows. So like, it doesn't seem to be super duper bad, but it's starting to give me some issues with this new, technology. What book do you get?
It's just my car.
So you like gave up? I think. Oh, remember I was like, yeah, you gotta run that as administrator. Okay.
Oh, I didn't try to relaunch it. I just, yeah.
Oh, you just gave up.
I was like, yeah, I gotta take a break. Take a walk.
Okay. Time has come. Go back to the world. Virtual. Do what with me?
Let's do that review.
Oh yeah. Let's freaking do it.
I'll narrate.
Yeah, so everybody can hear every little thing we say. Yeah, there's a microphone. I don't know where the microphone is located because
Can you listen to music if like you put your headphones on?
yeah, you can. So I can hear like all the audio that's coming through because I have the browser pulled up. But if I just exited the browser and just had the streaming thing going, then okay, cool. Yeah, the audio's working, so I don't need to hear myself. But cool. Yeah, let me bring this guy up. Yeah, dude, we should totally. I'm gonna make a company where I just hire tutors and they just tutor people through virtual reality. It'll be like Kumon, virtual reality Kumon, where people they can just be at their computer.
Well, you can help anybody because like they just bring you documents and you just like help them figure out how to do it virtual reality.
Yeah, like so it's a lot more intuitive, I think, instead of because online tutoring, if you just do it right through the internet, I don't know. I feel like this is such a good program to show things. Anyway, okay, I'm bringing them up. To put the JPEG files in? Oh, go to documents. So go to the start window thing. Oh, you found them all. Cool. Yes, you have to do JPEGs. All right. I'm doing the final test review. So right now, I'm just doing these integrals. So, here's the one that I wanted to do, number 4. So find the area of the surface obtained by rotating the curve y equals root 9 minus x squared from those guys. So I think the formula is integral of 2 pi, or no, 2 pi integral f of x times square root of 1 plus, then depending if it's, so this one says the x-axis, so we're going to have dx. So I think it's going to be dy over dx squared, and I think that's the formula. So if our function is root 9 minus x squared, and then we're going to multiply that by 1 plus the derivative of 9 minus x squared is negative.
So it's a chain.
Yeah.
So first it's going to be in the root, right?
So you're going to have 2x over 2 root 9 minus x squared.
No, you know there's a negative there, right? Negative 2x.
Oh, yeah.
Negative 2x.
Oh, yeah, so you have a negative x, yeah.
And then the whole parentheses is squared, right?
Yeah. Oh, yeah, there we go. Yeah, so the negative doesn't really matter. But yeah, there is a negative there. Yeah, this guy is more important. So when we FOIL it out, we get 1 x squared over 9 minus x squared, and this is all within a root. We're multiplying these roots together. So when you multiply them out, then you get 9 minus x squared plus x squared is no, that doesn't seem right to me. I feel like there's something wrong. Because then I'm just less. Okay, well, this cancels out with this. So I just have a 9 minus. I just have a 9. Root 9. Root 9 dx. Ooh, I have to get rid of this. It was pretty funny listening to you. Because I realized that you didn't know that I could hear you. So you're like, rainbow? That's crazy. Like, whoa. Okay, so we have root 9. And then, oh, it's from negative 2 to 2. So, I'll just turn down the brightness. So we just get 9x. Negative 2 to 2. This thing? Oh, this is missing something? What is it missing?
No, the formula is good.
Oh, the formula is fine. Okay.
We forgot from that formula.
I forget. I have 9 minus x squared plus x squared. So this thing. No, this thing right here. Of f of x, root, oh, it's underneath a root. Oh, it's a 3. It's a 3. Oh, I pulled it out right here. So we get 3x. Oh, so you get 6x, right? I feel like I got a different answer when I did it before because I've already done this problem once. So we get 6 or crap, we get 3x evaluated from multiplied by 2 pi negative 2 to 2. So you get 6 minus negative 6. Oh, no, this is right. 24 pi. Okay, makes perfect sense. That wasn't hard. Okay, cool. Yeah. Okay, this guy's the differential equation. Oh, that. Excuse me. Sorry, Wicket. So you didn't finish building your forest?
No, I didn't.
Oh, it just crashed. I wish I could like throw this and then teleport instead of like having to drag it with me like this. All right. Here we go. So we have solved the dE. So we have dy dx equals y squared sine xy. Y squared sine x. Yeah, that's it. Sine x. So uh, I don't think, no, this isn't that hard. So I'm gonna have dy 1 over y squared equals sine x dx. And then from here, do I just integrate both sides? And then integrate. Ooh, that's a nice contrast. Yeah, I realize like colors on the opposite side of the circle thing are, complete clashing colors. So, um, so let's see, what am I gonna get? I'm gonna get negative 1 over y. Did I do that right? Y negative 2 plus 1 divided by negative, yeah. So, yeah, negative 1 over y equals integral of sine is negative cos x, and then press C. And then flip everything, so I'm going to have y equals 1 over cos x plus C. Oh, it's a constant, but I guess it doesn't really matter. But so I guess, yeah, he's the guy. He's the guy. It's kind of cool. Like there's like this flat level of line, and then it moves down to this level, and then this level. So it's like steps. Okay. I wonder if where's the other JPEG file? Yeah, we're streaming. I don't know how many people are actually watching. If you look at this doesn't tell you. I think if you go to click that, yeah, that thing right there. Yeah. Oh, nobody's watching except for us. But people can. We need to become internet famous. That's the goal, huh?
Does it save these videos?
I think it does, because if you look past, like, I can see, the previous like 2 hours when I was just, setting it up and like doing problems on my own. So I think so. Like, I'm sure if I were to like, because I would go onto like Reddit and like post it, I'm sure I could get people to start watching, but I don't care too much. Or if you posted it on Facebook, I'm sure you could get some of your friends to watch. Okay, this initial value problem looks like it's another DE. Um, let's see. So we have T dy dt plus 2y. Oh, so another cool thing I managed to figure out is if you hold which button is it? If you double tap this button, it inverts the color. So like when you have the Tron vision, it's wait, I'm trying to.
funny. I'm just watching it on YouTube.
Man, I can't get rid of the crazy Tron vision. Okay, here, you just have to see this for yourself. Here, put it on, and I'll show you what you mean. So double tap the bottom button. Did it work?
Yeah,
Do you see the inverted Tron vision?
it's always like this.
Wait,
Yeah,
wait. What do you mean? Well, like it's not anything new?
it's just the same blue.
No, but it's like inverted. Like you can see more. Like
It's just actually all on. That's all.
yeah, it's all
Same,
on.
It's always like that.
And then here, get this. Here, put it on and look. So when you hit the dashboard.
Which one's the dashboard button? This button?
Well, no, it's already on. It should be.
Yeah.
You see the camera? Like look at your controller.
I see two controllers. Yeah, it has a self cam. I saw this. Yeah.
Freaking awesome.
Crazy. Yeah. Yeah. So what's it doing on the broadcast right now?
Oh, I can't see the overlay that you're seeing. I can only see the game.
Okay. So how do I go back to the game from here? This is
Click the bottom button. Should go back, right?
now I still got the crazy Tron vision. That's awesome. And I got this. That's super cool. All right. So what are we doing here?
Okay, we're gonna do.
I need to get my controller back. I don't know my menus for some reason. What's up? I don't know my controllers. Like I can see them, the virtual controllers, but they don't have the. I can't see the tilt brush part. Can you see this?
Oh, here, let me see.
Okay, here. I can't see the tilt brush.
Oh. Yeah, because you have to double click it. So now you can.
Oh, there we go. Go back. All right. Want to do one? All right. What are we doing?
We're gonna be doing solving initial value problem.
Do you want to keep being in the VR or?
Oh, sure.
This seemed to make more sense.
Yeah, it did, huh? All right. Like a little piece of hair tickling me. Yeah, the foam is so fine. Sometimes your hair can get stuck in it, like maybe from your haircut yesterday. Oh, maximize it maybe?
No, like taps on. It's kind of funny.
Huh.
It doesn't matter actually because this is actually better.
Yeah, so if you bring up the Google Tilt window. So initial value problem. So what I want is a first order linear differential equation, right? That's my dream. So how do you know that it's it's a p of x. Oh no, dy dx. No, this is like the thing. Dy dx. Here, let me do another color. Dy dx plus p of x equals q of x. Right?
Okay. You need a y next to
Oh, okay, yeah, that makes sense now. Okay, cool. So, um, probably what I should do is factor out that t. So I'm gonna have dy dt. Here, let me put this guy behind me because it's still a lot of light from it. Plus 2y over t equals t squared. Now, to find our I of x. What? Did you send it to him?
Because he commented and was like, dude, didn't we talk about this? Exact same project? And I realized we did. This is exactly what we talked about.
What, like a long time ago?
Yeah.
What?
Years ago at a hackathon.
If you're like, hey, what if you could have virtual reality paint?
Virtual reality school.
Oh, virtual reality school.
Why have schools? Have virtual realities and then have a gym
Yeah, if if you had multiplayer with this, because then you could both be in here and you could walk up to each other's whatever you draw and
Sorry, so yeah,
oh, integral. Okay, so we're gonna do so e to the integral of. So this is my p of x, right? Well, I'm gonna be doing it in terms of dt, I believe.
Are there going to be any y's? Do you need the y's? The y is actually part of the p. Look at the original equation. The y is part of the p.
No, no. This is this 2 right here is just p of x, right?
And now,
Well, and well,
go down.
th
2 over t, because here you have the circle is 2 over t.
this guy. Okay, that makes sense. So 2 over t dt. So we can just pull. So we have ln of t squared, ln of t squared to the e. So these annihilate. And then we're left.
Oh, I see what you're saying.
Yeah, because I pulled out the. Yeah. Mm-hmm. So, yeah, so I just have t squared. So this t squared, now this is where this is where my understanding is weak. So from this point, I'm going to multiply both sides by this guy, and there's something with the chain rule going on. Okay, so I'm going to take him, and I'm going to do t squared times dy dt plus, and this is 2y t equals, right? So, now, this is where you're gonna have to explain a little bit because I don't really like. There's something where I integrate both sides, and then this dy dt gets canceled, and then there's a chain rule going on where it's like.
So distribute the t on the left.
Okay.
Focus on the left, because that's where all the crazy shit's happening, right?
Yeah. So dy dt. Is your friend watching? Yeah, just send him the link. Just go to my Facebook. Go to my Facebook page, my profile. Yeah, on yours. And then you can just share it. Okay, so plus Oh, I see here. So I just have a 2ty equals, yeah, t to the fourth.
So looking at the left side, what rule are we?
Chain rule, right? Product rule. Oh yeah, product rule. Not chain rule. Okay, so I have to teleport myself because I've run out of room to move. Oh, I'm up. Oh. Um. Oh, I've hit the invisible wall. That's why it's okay. So now, I can just write over here. So so t squared times t prime plus 2ty equals t to the fourth. So this right here looks like uh, the derivative of this, right?
Yes, exactly.
So what? So I haven't yet drawn the connection between this part.
Here's what you're gonna write. So you're gonna write in the next line. You start with just d over dt,
Mm-hmm.
and put a big bracket. And we're gonna say that both of these things that we're looking at, t squared dy dt and 2ty, are both part of one product rule between two functions.
So I'm gonna write t squared 2ty.
It's just gonna be t squared y.
Okay.
Does that make sense? The blue thing is the result of the product rule on the purple thing.
Yeah, this right here, when you take the derivative. Oh yeah. There's a product rule because you're multiplying.
And then y, if you take y's derivative, you get dy dt.
Yeah, you get dy dt. You take this guy, you get. Hmm. Hmm.
So it's a product rule. If you differentiated t squared y, you would get the symbol in that. No, you would have to do a product rule.
Oh yeah.
They're two separate functions.
Yeah, you would get. So you would have t squared. Here, I'm just gonna do the product rule just so I can have my understanding. So I would do this guy times that, so 2ty plus t squared dy dt. And what do you know? Holy crap. It's the same thing. I get it. Cool. I see it. That's why. And that's why. Okay, so so what you're saying here is the derivative of this thing right here, and then if you're to, this is the equivalent. This is the equivalent to that. So now you integrate both sides. Whoa. And now I'm gonna have to teleport.
So you have d over dt in brackets is the y equals. Teleport somewhere else.
Yeah, I chose a really crappy place to do this problem. That's okay. That's not like the best, but
Go to a home spot.
okay.
Away from the wall. Get away from the wall.
Yeah, I'm like in the center of.
So write t squared dy.
2ty equals t to the fourth. So d dt of t squared y integral equals integral t to the fourth. So this right here just cancels out. And so we're left with t squared y equals t to the fifth over 5 plus c. And then you divide both sides by t squared, right? So I'm going to have y equals t to the seventh over 5 plus c. Is this? I feel like I'm doing something wrong, but. And then that's it. You just. It was initial value problem, so they just wanted.
So okay, so
What do they want?
go back. Here,
On
I'll
the.
tell you it's right. I'll tell you it's right.
Okay.
Right, yeah. There you go. Write the original equation. T dy dt plus 2y. Just the left side.
Plus 2y equals. What again? T cubed?
T
Cubed.
y dt plus 2y. Just write that. Equals. Don't write t cubed. Don't write t cubed.
Plus 2y equals what again?
Don't write t cubed. Erase t cubed.
Oh, it's gone.
No, it's still there.
T cubed?
Yeah, get rid of it. No, leave the equals. Leave the equals. It's fine.
Oh, looks like there's some latency. Oh, you're watching the actual stream, that's why. You have to watch the.
Yeah,
There you go. Yeah, there's latency with that.
okay. So yeah, leave the equals and then put your function in for y.
Oh. Oh, okay. 2, so t to the seventh, 5 plus c over t squared. And then they said y of 1.
Put its derivative in for y prime.
Oh, what's the derivative again is.
You don't have it. You have to take it.
Oh, I have to take the derivative of this? Oh, crap. Well,
Not so bad. See power with that.
okay, so it'll be 7
Mm-hmm.
7 over 5 t to the 6 plus c over like 2t cubed.
It's going to be negative 2.
Oh, yeah.
2's on the top.
Oh, yeah, you're right. So he's going to be just minus 2c over t cubed.
Yeah, put that in for right then.
Okay. So I'm just going to. So t plus. And then I said 2y and then equals, what is it, t cubed?
Mm-hmm. No, don't write 2. You already got enough to do this section.
Okay.
So it's that.
Well, do I just, well, I start simplifying, right?
Yep. So we can multiply in t here, right?
So we get 7 fifth t to the 7th.
Another t to the 7th now in this equation.
Yeah, he's over here.
Diagonal. That's 2 fifths to the 7th, right? forming at the other t to the left.
Oh.
Yeah, go back to that action. That's what we were doing.
Mm-hmm.
You just pause to grab all the other t seconds.
Okay, and then minus 2t c plus c over, or 2c over t squared.
What's with those
Oh,
last
yeah.
two?
Yeah, I don't know why I have 2 overs.
What's with those last two fractions you just made?
Well, I would have to multiply this guy by t, so I would have to add them, so t cubed plus this guy. So what do you know? They annihilate. Hey, that's a good sign, right? And then, what the hell is this? Is it a J? 2 to the... What happened to my 5? Okay. 5, so... What the hell? So I have 9 over 5 t to the 7th. 9 over 5 t to the 7th equals t cubed. Yeah, so this is what I'm left with. Okay, I guess I'm just going to solve for... So I'm going to have 5 ninths equal t to the 4th. Should I just am I supposed to be solving for t? Okay, so I'm just left with this.
9 fifths to the 7th, right?
Yeah, equals t cubed, yeah.
Yeah, it doesn't equal t cubed.
Oh,
Something wrong.
well, what does the original problem say?
Go back to our, we're doing good. That's fine. So look what we got back to the left.
Where, this?
Yeah, and go back to our work here. Something's funky. I'm not sure what it is.
Huh. Do you want me to go back over there?
Oh, I see what you're saying. Wait. Look at this. Is our plugin good? Did you put in this plugin? You didn't screw anything up here? Yeah, we're fine. Well, our C is fine. Yeah, so go back to the original equation.
Okay. Teleport. Teleport button. Man, Wicket, you are like...
Oh, no, yeah, right here. Go back to where you were. You were in the right spot.
Right here or over there?
Yeah, go back to right when we rewrote the equation. At the beginning of this stream right here.
So right here? Am I at the right spot?
Go to the beginning of this computation.
Okay.
Where is that?
Well, we started up here.
No, before that. Yeah, there.
Oh, over there.
That green right there.
Okay.
Okay. What do you do after this green?
Um,
Do the next thing without looking at what you did before.
okay. Well, I guess I'd be solving for y. So, I would have, let's see, 5y equal t cubed plus c over t squared. And then I would divide, so I would have y equals t cubed over 5 plus 5c over t squared. This is getting like crazy. Okay, so yeah.
we had in the next line.
Yeah.
Before we did this, because here we did a second take on this conversation.
So this guy?
Look up and to your right. Yeah, look up and to your right, and you have what we did before.
So this right here.
No, up and to your right. Like,
Oh,
look at the next step that we took last time.
tell me colors.
Oh, purple. Yeah, look at the first purple, right?
Okay.
No, sorry, right. That, yes, right there. Now go back and look at what you just computed. The green.
Yeah.
The end of your green.
So this right here.
Look at the end of it. Go down.
Oh.
Green, right?
Yeah.
The bottom of that. Your box one. Look at the two things you just boxed. Not the middle thing. You should not have that box. They're not the same.
No. So something's wrong.
The one we had before was
Oh.
the one we have now is correct.
Oh, so this one is correct.
No, that was wrong.
This one's correct. The one in purple. Box in purple.
The green text purple box. That's right.
Okay.
You fucked up. You found it out with what you need, but that's not really a very nice way of having fun.
Yeah, I'm like,
That, however, I believe is actually
here, if you grab my iPad, I think.
look back what you got.
I can always do it again.
That works out. That makes sense. That's awesome. So, yeah, why don't you just plug that guy back into the equation? Let's check again.
Okay. I walk over here with my paper. And let's lean over here, put him over there. Let me teleport. Ah, okay. So, we said that ink. Okay, so we have y equals t cubed over 5 plus 5c over t squared. Alright, let me teleport over here and plug into my. So just write down the original equation. Okay. T dy dt plus 2y equals t cubed.
So we'll plug our function into the left side. Let's see what it's.
Okay, so we have a t dy dt. So should I take the derivative?
Yeah.
Okay. Yeah, as only is 2 times. Oh, so we just want this to equal t cubed, and then. So because they said that f of 1 is 0, that means that they want us to solve for c, right? I don't think so, no, because this is constant, right?
Yeah, no, to solve this problem, all we really need to do is solve for c. Because we know that we've got the correct answer.
Okay, so the derivative of that guy over there is so we're going to have a 3/5 t squared plus negative c over t cubed times t plus 2t cubed over 5 plus 2c over t squared. So do we care about this 2c, or can we just call it c still? Like,
We use yes.
okay. Yeah, we don't care.
Wait, no.
Because there's a 5 there and I got rid of it.
No, because the 2 didn't come from us plugging in the C in the first place. It's a plug-in, so that C value has to be fixed. Because one C value corresponds to one Y. So if you change the C, you're changing that one to one correspondence.
Oh, so it's 10. Oh, it should be 10 then. Okay.
No, because the 5 was different. The 5 was before we plugged it.
Oh.
Go back to the white and erase the 5 from the white. You do that because you haven't plugged it in yet, right?
Oh, okay. Ooh.
Now we're gonna die.
So now we just have 2C. Okay. All this stuff. So we get so we get 3t cubed over 5 plus negative c over t squared plus 2t cubed over 5 plus 2c t squared equals t cubed. So we get a t cubed plus. Yeah, I feel like I should just start over. I feel like I have so much. So this we get we do get a t cubed, but
Wait, that C right there should have a 2 in it.
this.
Yeah, this is derivative.
Oh yeah, yeah, I see. Okay, so yeah, so we get t cubed equals t.
So it works, right?
Okay, so when in doubt, just plug it back into the equation. And
Plug in the left side, see if you actually get the right side back.
so this guy.
The left side, right side.
So this guy is the answer.
Yeah, so then we still got our initial value problem to solve.
Oh yeah.
Initial value problem is 2 parts.
So y of 1 is, yeah. So I don't need it. Okay. So what they're saying is y of 1 equals 0. So when you plug y in, so it is a function y of t.
Yes.
So when you plug 1 in for t, then you get 0 for y. Okay, so 0 equals 1/5 plus c, so c equals negative 1/5. And then there you go. There you go.
Just write the function again.
Oh, okay.
Circle that. That's cool. Now we rewrite the function.
My arrow. Yeah. All my vectors. Vectors, those are like directions in a three-dimensional space, right? Well, yeah, 5t squared. Is anyone watching now? The idea of like people watching is kind of fun. The math. Look at all the math. Oh, scroll down. Go back to the. I don't think anybody's watching. Nobody's watching. It's being recorded though, which is kind of cool.
We could share it.
Yeah, how do you do that?
We could just share it to Facebook.
I already did. You would have to share it. So everybody sees that we both share it. And then I think the algorithm picks up and
Here. I can post it.
yeah. Yeah, then share down here. Everybody watch! Yeah, Mohammed from my calculus class, he was watching like earlier this morning. He was watching me do math. It's like, oh, you're doing the review. Let me follow. So another cool thing that you could do is like you just sit on the couch. So instead of standing, you just teleport around. So what? So the paper brush, it's it's completely opaque.
It's one of the best ones. Alright, let's go on to the next one.
So you can use it to block out sunlight. Or
You just like save this and clear it.
yeah. Here, I'm gonna try and be organized in this new world. Brave new world. So to be organized, I'm going to start in the middle. Well, yeah, so here's the middle. Okay, I'm gonna use this pedestal as a reference point, actually. This is kind of a cool one. So I'm going to watch this. Oh, sorry, Wicket. Making like a board almost. Organizational skills in VR. Okay. Okay, so let's do problem. Ah, yes, the parametric equation. I don't recall very well how to do these. So let's do it. I can change my environment now. Okay. Find all points, if any, of horizontal and vertical tangency to the curve given the parametric equation. So we have, what is it, y. So x equals t plus y. Oh, I still have the x equals t plus 1, y equals t squared plus 3t. So if I remember correctly, you do something like you're gonna make a table. So we're going to have x, y, and t. So you plug in values for t. So when t is 0,
y equals 0 and x equals 1. When you plug in 1, you get 4 and you get 2. When you plug in -1, you get, let's see, 1 minus 3, so you get -2, and you get 0. So do I need any more points? Yeah, so find all points, if any, of horizontal and vertical tangency to the... Oh, like draw an actual graph? Okay. Oh, that was just so I knew where the center of the room was, but yeah, to check this out. So you have a mirror tool. Nope. Yes. So it's going to be this way. Oh, whoa, no, that's not what I wanted to do. Okay. This ain't no rudimentary graph. I think if it like clicks green or something and it like, I think it's, okay, so, I wish I had a ruler, but, oh no, you can do, no, you can do, yeah. So 1, and you can make it symmetrical. So this is actually perfect. And then, oh yeah, if you rotate it, yeah, I just thought, so you would rotate it. Yeah, dude, that's cool. 2, 3, that's good, right? That's a good VR graph. Mm. Okay. So when x is 1, y is 0. When x is 2, y is 4. This is actually pretty cool. When x is 0, -2. Okay. So it goes -1. Oh, I didn't do this in a very intuitive way. Huh. Because it goes...
It's not doing it for us, right? We don't know, like, the interesting things.
Mm-mm.
We don't know anything about this graph.
Nope.
It's a bummer. Where's like a maximum for y, a minimum for y?
Maximum. Well, I think, can I just plug in more points?
Well, can we take the derivative of the y equation?
Yeah. Oh, where you and set it equal to 0 and see where the...
Yeah, and then now it tells us where the each point's plug in, right?
Ooh, that's nice. That's kind of cool. That's way cool.
So take dy dt dx.
I'm having too much fun.
Don't mix too much back in, you can't do it from the other side.
Oh yeah. Okay. So okay, so yeah, so dy dt equals 2t plus 3. So now I set this equal to 0. So y prime of 0, you get 3. Right? So what I want to find dx dt? Well, dx dt, I just get 1.
Okay. What about dy dt?
dy dt, you get, well, y prime of 0 is 3.
3. So, no. When is it 0? I don't care what it is when t is 0.
Oh, set it equal to 0. Oh, you would get -3 over 2.
Yeah. So what does that do when you plug it in for x?
You get x equals -1/2.
Oh, well, we should plug in points on like either that point or points on the other side of that point, the one we plugged in. We should try to bookend. We should try to find t values around -3/2. Plug in some ones on the other side and see what it looks like.
Okay, so plug in this x value for this guy over here.
Well, what was t? What was the t value?
-3 over 2.
Go back to your chart. What t values did we plug in?
0, 1, -1.
So we can do like -2 and -3.
Yeah. So -2. We're going to get 4 minus 6, so -2, -1, and then 2. We get.
Not 2, -3. We're going around the point -3/2, right?
Yeah. Oh yeah. Okay. So -3. So we're gonna have 9 minus 6. We have a 3, and then x. Oh wait, yeah, I'm retarded. So we have 0, and then we have -2 for x. So we can plot these now. So when x is -2, y is 0. When x is -1, y is -2. So we have
What does that look like?
just the y values or the entire.
That plots we just made, all those points we just made.
Well, I need to see. Let's see. Where's t of 0 is here. So it goes here.
It doesn't matter what order they're in. Just look at them ignoring this. We should just remove t from the equation. Look at x. Go back to x. The x equation.
That's a line.
Solve that for t.
Oh, okay. T equals x minus 1.
And put that in for t in the y equation.
Okay. So we have x minus 1 squared plus 3 x minus 1 equals y. So we have x squared minus 2x plus 1 plus 3x minus 3. So we get x squared plus x minus 2. So it's a parabola. Let's see. You can factor this to be what? X minus 1 squared. X squared. That's not right. What would that factor out to be? X minus 2.
No, just look at the points you've got. You drew points on the graph. Just connect them with the line. They're points. Look, it's a parabola. Yeah, just draw a parabola. It looks like a lens. No, it can't be curved that way. Look at the other points. Okay.
Yeah. Okay.
Alright. Where is it 0? Where does it have? It needs a horizontal tangent or a vertical tangent.
So here's a horizontal tangent right here.
We already found that.
Oh, t equals negative.
Yeah, draw that horizontal tangent on there. big box around that too. It's clearly that's the horizontal tangent.
Oh.
Sorry about that.
Oh, yeah, I didn't realize where I was. Okay, and then
So then did we find out if there was a vertical tangent? We
no.
found the horizontal tangent by setting the y dt equal to 0, correct?
Yeah,
How would we find a vertical tangent?
dx dt equals 0. Well, it doesn't. Well, it can't be 0.
It doesn't. So are there any vertical tangents?
No.
Does a parabola have a vertical tangent?
Nope. So the answer would be when t equals -3/2, there's a horizontal tangent.
Exactly.
Okay.
And all we have to do, just to reiterate, sorry we're doing it the wrong way, is just set y dt equal to 0 and set dx dt equal to 0.
Makes sense.
And we give you the horizontal.
Cool. Next problem. Should probably walk over here and then teleport. Hey, there's a nice stool here, huh? Yeah. Okay. Let's flip this around. So now we're gonna do. Oh, this one's a bitch. But this will be fun to draw. Okay, so let me set up my graph. Let me sit down on this bench too. Oh, I have to walk over there and grab it. It like stays in its last position. The mirror tool. Okay. Man, I've been like standing probably for like 4 hours because of this freaking VR. Stand a lot using this thing. Okay. Oop, that's crooked. Yeah, that's good. And then flip him this way. Okay. Oh, I have to show you something cool. Dude, watch this. Okay, are you watching my screen? Okay, so you can spin the mirror. So you could make like a sphere. Yeah, like as it spins, there's symmetry. So I don't think there's any on the review, but I can find some just to do because we have VR. You can tell them about the thing we're gonna do on Monday. Just be like, hey, if you want to try it, well, if they're listening to the broadcast, yeah, IVC, talk to Ted, be there Monday at 2 p.m. after I take my Calculus 3B test. You'll be able to play. We're gonna play Keep Talking and Nobody Explodes. So you're gonna put the VR headset on, and somebody has to disarm a bomb, while everyone else outside of VR has a PDF file that will give instructions how to do so. All right, so what is this problem? R equals 3 cos theta. R equals, oh, I should probably write it away from the graph. R equals 3 cos theta. And R equals 1 plus cos theta. So find the area outside, so outside him, but inside this. Okay, so this is a circle centered at multiply both sides by r, so you get 3r cos theta. So you have x squared plus y squared equals 3x. So you have x squared minus 3x plus y squared. So, okay, so it's going to be centered at a diameter of 3. So it's going to be like 1.5, something like that. How many people are watching and how many of your friends? Okay, so nice. Okay, it's okay. So we have so outside this circle, which has a diameter of 3, right? So it's like the center is 1.5, and inside this cardioid, I think it's a cardioid. So what? So there's 1, 2, 3, 4, 5. So let's rotate this mirror. So we're gonna have 1, 2, 3, 4. You know, it'd be cool to get a JPEG file of a ruler, and then you could throw. Oh, yeah, you could. Actually, it'd be kind of cool to just import a big graphing thing for problems like these. But okay, so centered at 1.5, so 1. So here's the center. Here, let me do another color. Center here, so like it's a little off, but it's something like, oh, that's a crappy circle. There has to be a tool in here to draw a perfect circle. I guess there isn't.
Can you look in the image folder?
Yeah, what'd you put in there? I don't see anything new.
Okay, I'll give you GIFs.
Yeah, it has to be JPEG. So just go to that website and then download it and drop it in. Oh, you put one in? Oh, ooh, what's that? I just see a black square now. Oh, there it is. Oh my gosh. Oh my gosh. Oh, the quality on this is terrible though. Yeah, I have to make it super teeny tiny and I can barely read it.
You just use the lines as guides. Why is it returning the results? Larger than
Oh, that's cool. Oh no, actually, yeah, you have to be sitting. It's a little fuzzy, but yeah, it's good. And
why it's doing
you just download tons of viruses.
that, like searching for larger
Yeah, my scale on the circle's like really bad. Here, time to fix my graph. I don't like my graph. Yeah, I'll just use this. This is a lot. This is nice. Back to my brush. All right, cool. So we have 1, 2, 3. So yeah, like right here is the center. So 1, 2, 3. So it's something like centered here and a diameter of, yeah, so this is going to be, there we go. 1, 2, so I just want to draw a perfect circle. Something like that. And then a cardioid of r equals 1 plus cos theta. So if r squared plus or equals r, well, I want to see, well, how would I graph this cardioid? I forget.
For this guy,
Just plug,
when is r equals 0?
at pi.
Okay. Then check the other four values of pi.
Wow, like negative.
Like plug in the four cardinal directions.
Oh, okay. So here it's going to be 2.
That's one.
Oh, oh yeah. Man, I'm having difficulty graphing. It's a lot harder than it looks.
Make it bigger. Do two circles per one. Make it bigger.
Okay.
Don't stress so much. Like when you make a circle, just swing your hand in a circle. Like you think it's a circle. But go like yeah, 2 check marks or 3 check marks per one. That paper's too precise. Or just sketch your own in front of it.
Yeah, I'll just use like,
And then sketch a couple of the circle rings, and then throw away the picture.
yeah.
And make the circles like pretty big. Because the biggest we need to go is 3, right? So really outside that should be 3.
Cool. Get rid of that thing. Okay. So, oh, I should have used it for ticks, but whatever. So that's 3. So this is going to be, yeah, roughly 1.5. I only have a mirror here. Yeah, 1.5. So, and then, so how high is the circle? Yeah, that's good enough right there. And then for the cardioid of r equals plus cos theta, so this is 1, that's 2, and that's 3. So when r equals, when theta is 0, you have a point here. Pi over 2, you have 1.
So it's V1 going straight up. Up from the origin.
Oh,
And theta equals pi over 2.
yeah, and then here it's a 0, so it's something like, okay, there we go. And then,
Do it with the
yeah,
don't make it so
shitty.
intense. It's not as intense as
No, it's not. It's just hard to draw a nice circle on one go. Oh, I actually have an idea using this mirror. Is this gonna make it do it? Okay. Oh, I have to do it this way. Oh my gosh. Come on. Oh no, it's like spinning on a. It's really hard to make it just perfectly flat and spin.
Yeah, you can't use the rule at the same time, I'm guessing.
No. Oh, wait. Spin. What? This. Okay. Okay, it failed. Failed attempt.
Oh, this looks so cool in the live stream.
Okay, there's my. That's a better circle. And then we have what? There's 1, 2. So then we have something that looks like. Oh gosh, I didn't use the mirror. That was the whole point.
He's also supposed to cross 1 and 5 or 2.
He's what?
So he's supposed to cross 1 in the direction 5 or 2. He shouldn't be so high up. It should be the same as the first red tick mark. Like put tick
Oh,
on the y-axis also. Yes.
okay. So yeah, so we start here.
You're only going to go 1 on the y-axis, so you're not going 40 tenths.
Man, that is the worst. That's like a penis. Okay, there's my cardioid. Here, one more time. One last attempt. You know what? This is 1 point. This is 1/2. This is 1. There.
Well, get rid of the half tick. Just get rid of that.
Okay. Here we go. Okay. So, what did I say? Outside the circle, but inside the cardioid. So, we want this area right here. All of this. That's what we want. Hey, that's actually quite nice. So, we want to know what this intersection point is. And this intersection point, right?
Yeah.
So this green shaded area, that's gonna, well, that's why you integrate. You just
You
can't.
don't want the green shade there.
Oh yeah, duh.
So you need to be careful with the green shade.
Okay, well let's set this equal to 3. Uh, let's set them equal to each other. So, where the hell am I doing?
The green shaded area also shade it red.
Okay.
Because it's also part of the red area, the one you integrate, right?
Uh-huh.
Yeah, so it's green.
Okay. So now I'm just gonna teleport a little behind to do my math. Oh, watch this. This will be cool. So if I go here and I put some, I select the paper and I make it black. Look at this contrast. Okay, so yeah, that looks nice. That looks way good. Check that graph out. Never seen such a beautiful graph. So I'm gonna go back to my marker. So we're gonna do 3 cos. Ooh, actually, let's not do that. We're gonna do some orange, bright orange. So 3 cos theta equals 1 plus cos theta. So we have cos theta equals 1/2. So what equals 1/2? Pi over 3. And crap. What is that? So add okay, negative pi over 3. Let's just do that. No, that's bad. We don't want to do negative pi over 3.
So what are you doing here?
the points of intersection. So cos theta equals 1/2. So we have pi over 3, which is right here. And then I'm brain farting on how do I...
When we hit that, what is that?
Like...
Pi over 3 less than 2 pi, right?
Oh, okay, so this is 2 pi.
We should add 2 pi to negative pi over 3.
Yeah. That's what I'm doing. Okay, so we have 6 pi minus pi over 3. Okay, 5 pi over 3. Cool. 5 pi over 3. Now there's an equation that I should know. Let's see if I remember it. It's, what is it? Let's see, the integral. So we're going to do integral from 5 pi over, no, which, how do I know which is b and which is, oh, no, it's going to be 5 pi over 3 because our starting point is pi over 3. And the equation is, do you remember what it is? It's like 1/2, 1/2 r squared d theta.
So you have to do 2 integrals.
Yeah, so there's gonna be one for the cardioid and one for the yeah. So first one is going to be so 1/2 integral pi over 3, 5 pi over 3. So we're gonna have 3 cos theta squared d theta. So this is the circle. So we want outside the circle. So we're going to do the cardioid minus the circle, right?
Yeah, exactly. Circle of different points.
Will it?
Yeah, because we don't actually have to go all the way around to get all the circle, right?
Oh, so what's the limits for the circle? Yeah, we just did for the cardioid. Are you talking to people? Nice. Okay. Yeah, so anyways, I'm going to do 1/2 integral of pi over 3. 5 pi over 3. I'm going to go to darkness land. Darkness. Ooh. Darkness is. Alright. Select this brush. So we have 1 plus cos theta squared minus that, and I don't know what the bounds for this guy are. Could I just do from 0 to pi and multiply it by 2? So,
Pi over 3 with pi over 2.
oh, for here?
Yeah. For the top half. So look at the top half and think about where that angle is going. Once you get to pi over 2, there's no more circle.
Oh, that makes sense. So I would just multiply this by 2,
Exactly.
and then these would just annihilate to 0. That makes sense. Oh, I don't know what, yeah. 2, 1. So it just goes away. Yeah, it's not there anymore. All right. I set them up. Got to do it. So let me just go back farther. So I have cos squared theta plus 2 cos theta plus 1. And then integral with a 1/2 in front with bounds pi over 3. 5 pi over 3 d theta. So I'm going to have wow, there's going to be 3 separate integrals here. So there's an integral here and an integral here with the same bounds. So I'm going to have, and then all of this is multiplied by, I remember why I didn't want to do this one, because you have to do a lot of algebra. You have to integrate like 5 times. How many people are you watching? People are like, that's cool. People really don't want to watch math for that long. Oh, okay. Cos 2 theta over 2. Man. Okay, so I have 1/2 d theta integral times 1/2 minus 1/2, or 1/4 actually, integral cos 2 theta. So finally I'm left with 1/8 integral of cos is sine. Evaluate pi over 3, 5 pi over 3. And then you have theta over 4. Ugh. And then I have that guy plus 2 sine theta pi over 3, 5 pi over 3. Plus just theta. Evaluate pi, yeah. So this is just for the cardioid. Oh man, dude, so much work. Well, look how much work has to be done. Well, look at the, like, are you looking? So this guy expanded out to this guy, which I expanded out to this guy, which is this, and then I just integrated those two guys on the right, easy. And then, well, I just do symmetry, so I just do, well, couldn't I just do from pi over 3 to pi, and then multiply everything by 2? That wouldn't really make it easier, but yeah. Well, now I'm just evaluating with these evaluation bars. So this is just the cardioid, and then I'm going to do the circle. Okay, so I have 5 pi over 12 minus sine of 5 pi over 3. Oh, shoot. Shoot, son. Forgetting my trigonometry. Well, negative pi over 3, that would be a negative 1/2. So plus this Oh, dude, this is so gross. Uh, minus pi over 12 minus pi over 3. What is that, 1/2? So 1. So I'm going to get 4 pi over 12. Why is it do I always like get into these corners when I'm doing it?
It's not necessarily a big space. If you move linearly, right,
Yeah.
you're in like the corner of the room. You move linearly, move some stuff out of your way.
I'm actually getting like tired. I'm like, oh.
Breaking the 12 on you, it's already tedious.
Ugh.
I think you're making some mistakes.
Ugh.
Take a break. Lay down a notch. Maybe I should like jump in the pool. I think I found some new graph papers. You can look at some of them that you gotta figure out how to get this thing. Cause I have a camera on here. What, how to stream it? How to stream it into there.
Well, I think, like, I don't know, with the program, this is limited since it's free.
Yeah. Can I just do this problem? I want to give this a shot. Do you want me to save this?
Yeah, it looks kind of cool.
Alright, let's see.
Really cool. Like, I never wanna-
Actually, I think there's enough room in this. Yeah, there's enough room around here. Oh, yeah, here's the other boundary. Yeah, so, like, the boundaries aren't that far, so, like.
So orient yourself to where I'm at. So you want to walk, like, up and down the room instead of the length instead of the width. Supposed to be the wall.
That should be about the corner.
Are you drawing the corner of the room?
Yeah, I'm kind of curious how big it is. Oh, yeah, so it's pretty. Oh, real world. So it's pretty good space, but there's not a ton of space. Alright. So let me see. Is this the best polar graph paper I got? Damn it, I can get a better graph paper. Where's my reference image? Oh, I'm still teleporting. Stop teleporting. Just go back to brush. There we go. No, selector? Where's my selector? Oh, it's a different button to grab this guy. Okay. Alright, cool. Go away, please. Alright. So now I need this guy to be a little bit brighter. There. So I'm gonna go have an axis that goes out like that. I'm gonna have an axis that goes out that. I'm gonna also continue him down. I'm gonna continue him over. I'm gonna go. Let's see. 1, 2, 3, 1, 2, 3, 1, that. That. Like that. I'll call this theta equals 0 to pi. Theta equals pi over 2. Cool. I have r equals 1 plus cos theta, which is going to look like that. And then I'm going to have r equals 3 cos theta, which is going to look like that.
Man, you're like way good at drawing those. Man, I was struggling to draw. I like the light one the best, just because you can get that glare. It just looks like the neon.
So this is my vision about how to use the paper. You just draw, like, you very quickly draw something and then like throw the paper away.
Yeah, it's very, very clever.
And then we're gonna get R1 equals R2
Three other human beings watching.
cos theta equals 3 cos theta. 1 equals 2 cos theta. 1/2 equals cos theta. Theta equals pi over 3. 5 pi over 3. Right? Cool. So then we're going to have
So you can just add a pi, right? No, that would be
so we're going to have, okay, area. That's no good. It's got to be a little brighter. Area equals area 1 minus, oh, that's the wrong color, isn't it? This is the color that this guy needs to be, is green. And then this guy needs to be blue. Area 2. Right there. This guy is going to be equals the integral from pi over 3 to 5 pi over 3 of 1 plus cos theta squared d theta plus, what am I doing here? Yeah, blue. Oh, no. Yeah. Minus the integral from Oh, it's funny. Okay. Okay, cool. Is equal to 1/2 the integral of 1 plus 2 cos theta plus cos squared theta is equal to the integral theta of 1/2 plus cos theta plus 1/4 1 plus cos 2 theta d theta is equal to integral 3/4 theta plus 1/4 cos 2 theta d theta.
I see what you did there to make it more simple. See, I got like only thing out. Just left them in. And I even straight when they did the cross. That's kind of smart.
Minus sine theta plus 1/8 sine 2 theta pi over 3 5 pi over 3, right?
Did you just factor out a 1/4? Or how did you get the 3/4?
3/4. So I had this 1/2 and this 1, which is getting this 1/4. Does that make sense?
Yeah.
And then the other 1/4 is going to this guy, which goes there, right? Yeah. So then here we go a little narrower with this. So this is going to be 3/4, and I'm going to have 5 pi over 3 minus pi over 3. And then I have minus sine of 5 pi over 3 minus sine of pi over 3. This is very exciting. Yeah, I guess I'm going to have to teleport a little over here. Yeah, there we go. That's better. Cool. Wait, that's really bad. Let's just rewrite that. There we go. And then clean that up a little bit. Okay. And what do I got? I got plus 1/8. Now I'm doing the sine 2 thetas. So I'm getting, I don't know, this ridiculous 10 pi over 3. Oh, it's sine 10 pi over 3. I'm sorry.
Yeah, that's why I was like, man, this problem sucks. It just takes a long time. You have to integrate like 5 things, evaluate them.
Minus sine of 2 pi over 3. Right? This is ridiculous. So, okay. So this whole parentheses is gone. I think. Is it? No, it's not. Oh, it's terrible. It's terrible.
You have negative 1/8 minus 1/2.
Okay, cool. Yeah, so then this is going to be negative. Yeah, this is negative root 3 over 2. This is negative root 3 over 2. So this is negative root 3. Right? I incorporated that negative in there. This guy is going to be just 3 pi over 3. So this is just pi, right? In there. And then what's 10 pi over 3 really? 10 pi over 3 is really going to be 4 pi over 3. Which is really just going to be pi over 3. Right? No. God damn. Oh, it's going to be the negative of this guy again. So it's going to behave like pi over 3. Yeah. So this is going to be negative root 3 over 2, right? And negative root 3 over 2. So we'll just have negative root 3. Right? So go to paper.
Who cares about the work? What about the 1/8? 3/4.
Right? So then we're going to have 3/4. And that's minus, right? And that's plus 1/8. That guy, right? Cool. So then 3 pi over 4. This is plus root 3 minus root 3 over 8. So, okay, so it's plus 7 root 3 over 8. This is area.
That's just the cardinal.
Yeah, so this is going to be area 1, right?
The circle is easy. Oh, the circle is going to be root sine theta from 0 to pi over 2 times 2. Or no, yeah. You have the 1/2. What is that? Sine.
I did like it a little bit fatter, actually. There we go. So it's going to be 9, and we're going to do the same trick again, right? One second. So this is going to be 9 halves pi over 6, right? Minus, when you plug in pi over 2, that gives us pi, so it goes away. So we just have the minus 9/4 sine of 2 pi over 3. And then sine of 2 pi over 3 is going to be... It's another rad 3 over 2, right? Cool. So then this guy is going to be... I got to go backwards a little bit here.
Yeah, this one's awesome.
Yeah, it's just long doing it this way, right? This is 9 pi over 12 minus 9 radical 3 over 8. Is equal to area 2. So then... Gotta make it big enough so I can see it. So then the area, there we go, is going to be 3 pi over 4 minus 9 pi over 12 plus. What's that?
3 pi over 4 minus 9 pi over...
Oh, yeah, I see what you're saying. Wait, one of that same button. What's the other part I wanted? Oh, yeah, it was that part. So it's going to be 7 radical 3 over 8 minus 9 radical 3 over 8. I hope we're not making math mistakes on the live stream.
Well, there's like not... No, we won't.
Did I just clock you? That's fucking funny. We totally are, because we're getting a negative answer. Oh, no, this is plus. This is plus. What am I talking about? Minus a negative, right? This is going to be 16 radical 3 over 8. Or 2 radical 3 is the area of this guy. What?
He did it in class. I have the answer. The answer's pi over 4.
Yeah, we're doing something wrong here.
Okay, so...
There should be a pi. It makes sense, right?
Yeah.
So where?
For the cardioid, he had different bounds.
What were his bounds for the cardioid?
These are the integrals. So for the cardioid, it's pi over 3 to pi.
Did he double it?
Yeah, he just doubled it. He didn't, so...
Yeah.
Yeah, you just went to pi and then multiplied by 2, so you got rid of 1/2. Then you get 1 plus 2 cos theta plus...
Yeah.
1/2, and then cos...
Did we just make a mistake because it's so much harder if you don't double it?
I think so, yeah. There's like a lot of work. So here,
So
right, cardioid.
well, yeah, we still end up having the same thing, right? We still have to do the whole integration. Oh, I see. It would just be the limit parts, right?
Mm-hmm.
Jesus. Let's see. It just comes when you plug in the limits. What did you get for the integral area?
Okay, so you got for the cardioid.
So I feel pretty good about this answer.
Yeah, so he had pi over 3 pi bracket 1 plus 2
Well, yeah, it was okay.
plus plus 1/2 cos 2 theta d theta.
Wait, say it again?
Okay, yeah, so we got from pi over 3 to pi.
Yeah.
Bracket, 1 plus 2 cos theta plus 1/2 plus 1/2 cos 2 theta d theta.
Yeah.
Okay.
Yeah, well, we had that.
Okay.
That's not my. Okay, that's
And
the.
then you have minus 9 over 2 integral from pi over 3 to pi over 2 of 1 plus cos 2 theta d theta. So why did you use pi over 3 to pi over 2?
That makes sense. Yeah, no. So what's the answer for each one?
Well, okay, so at the very end, the cardioid should go to negative.
Where's our math mistake here? This becomes 3 pi over 3. No, this becomes 4 pi over 3. Yeah, right here. Brush select. Eraser. Oh, no. Brush select. This guy becomes 4 pi over 3. And this guy becomes pi. Right? And this guy becomes that. Cool. Over here, this does indeed give us negative radical 3. And this gives us radical 3, right? Yeah, this is 4 pi over 3. Negative radical 3. 7/8 radical 3. Okay, cool. So then, no, that guy's a minus also. There we go, right there. So this guy has a minus also right there. So that becomes plus, so that becomes 9/8, right? Cool. So then, yeah, we come over here to this guy then, and we got to update this. So we got to select that brush. That will be pi. You will not annihilate. And then you need to be, nope, you need to be 9. Oh, yeah, select. There we go, 9. Nice. So then this guy is the one that is going to annihilate. So then we will. Yeah, no, we did everything right. We just made a few math mistakes in plugging them in, honestly. It's kind of stupid, but yeah, there we go. So then this guy will become pi over 4. Gonna make it super gay. Yeah, I like that graph.
Well,
Did any of my other graph papers make it in? I'm just curious. I don't want to do another problem, but okay. So then I try to get this one. How does this one work out? Oh, that one's pretty good, right? Think you could work with that?
let me see. Well, the rate thing. Oh yeah. Oh yeah, that one's way good. That one kind of sucks.
That one sucks. Delete that one. That one's no good. Oh, I'm teleporting again, aren't I? Yeah, let's yeah, turn maps off. That's good. All right. Yeah, it's good. It's good. People watching us?
I don't know, there's three people watching.
Nice. Who do you can't see who they are?
No, this is random.
I'm probably one of them.
Oh,
I'm watching it on here. Yeah, I don't know if you realize.
oh, then like nobody.
Who's the one other person?
Oh, so
There's one other person watching.
Juan Pablo.
Someone is watching us.
We love you, Juan Pablo Gallego. No, let me do one more problem. Let me do one more for Juan.
Juan Pablo.
Juan Pablo.
All right. Here we go. I'm just gonna let me save this guy. Oh yeah, you can communicate to the humans. Here we go. We are going to. Yeah. I'm gonna be doing it in white. White. Let me pull up the. Nope, that's not what I want. My reference images. Reference images. We want to go here. Man, what happened to the? Oh, you have to. You're looking at the feed. Look at the actual. Where the heck did the review go? Is this the review? Yeah, that's the first page. I don't want the first page. I want the next page. So that looks like the next page. Yeah. Here we go. All right. We went over convergences yesterday. Let me see if I retained all the information. I just got to repeat these things to do well on that calculus test. All right. Here we go. So determine the convergence or divergence of each series. Use. All right. So we have sigma n equals 0 infinity. Oh, excuse me, n equals 1 for this guy. 1 of e, or e to the n over 1. So this is a geometric series. So r equals 1 over e, so absolute value. So this is less than 1, so this converges, right? By geometric series. Okay. That's so like on the test, that's just all I would put. Okay. Next one. That was easy. Ooh. This one. Yeah, the series probably like 30% of the test will be on series, so these really aren't that bad though. Like for the scope of the class, it's not like we're doing probably the most complicated would be telescoping. But so this guy, what would be a good test to do? Yeah, and n can't equal 1 because then it would go to 0. So I'm just going to compare this to 1 over n. So b of n equals 1 over n. So there's a power here of 1. So this diverges. So if I were to do a of n divided by b of n, so wait, this isn't helping. Wait, n squared over ln of n, the limit of n goes to infinity. Yeah, that doesn't help. That's not a good test to do. Crap. No.
What's the first test?
Okay, so divergence test. So just take the limit of n to infinity of n over ln of n. So you have 1 over ln of. So this is equals infinity. So it diverges, right? What's the bad thing about the divergence test? If it equals 0? Oh, you have to mute the sound. So
What happened just now?
oh, wait, L'Hopital's. I don't know. Just just ignore what I wrote. Okay, so I do L'Hopital. Okay. Correct notation. Now I do L'Hospitals. L'Hospitals.
I don't think there's an S actually.
Really? Oh.
The O is a hat on it instead.
Yeah.
You know what the hat on the O means?
Yeah, it's like an open.
It means there's no S. That's literally what it means.
Okay. Yeah, so I have this guy, and when you take the limit of this, you get infinity. Oh yeah. Limit n goes to infinity, and this is equals infinity. So it diverges. So the divergent test, what we just did, the easiest one, it just tests for divergence, nothing else. So if I were to get 0, we wouldn't be able to use that. Okay, what's the next one? We have sigma n equals 1 of 1 over root. Oh, I know this guy. N to the 5th. So this looks like a p series. So what we really have here is 1 over n to the 5 over 2. So by p series, if p is greater than 1, it converges. Therefore, by p series, 5 over 2 is greater than 1, converges. Cool. I kind of like just like the white on black. It kind of sounded dirty. I like the white on black. Opposite. I'm gonna do just white in the blackness. Blackness. Darkness. Okay. Oh, that's trippy. Look at this. Because I wrote in black, so you can't see anything that I wrote. But as I bring this across, it's like a black hole. You can't see it. Unless there was light behind it, like in that one movie. What is this? N equals 1 tan of 1 over... Oh, I can't see. What is that? Oh, I thought they changed the noise. Okay, so we're going to compare this to b of n equals 1 over n. So, this is comparison test. So, how do I tell if 1 over n is bigger than b of n? No, limit comparison test. So I'm going to do a of n divided by b of n, right? Are you seeing this? Oh.
Alright, show me.
So I have tan. So this
Yeah.
summation of tan of 1 over n.
We're going that way.
So I'm going to compare it to 1 over n. But do I do b of or a of n divided by b of n, or?
It doesn't matter. Like, yes, you always do A1 divided by
Okay. So tan 1 over n divided by 1 over n. So I have limit n goes to infinity of So I get infinity, which isn't good. Yeah, I'm kind of stuck on this one.
You get infinity over infinity. Or you know, you get 0 over 0. Don't you? Because
Oh, tan of yes, I see. Oh, okay, there we go. I don't know why I wasn't seeing that. Yeah, tan of 0 is okay. Equal 0 0. Oh, that's weird. I can see the previous problem right here. L'Hopital's rule. So we get secant of secant squared 1 over n times negative 1 over n squared over 1 over n squared. These two things will cancel out with one another. So I'm just left with secant squared 1 over n, limit n goes to infinity. So we get secant squared. So this is just 1 over cos squared of 0, which is 1. So because we get a constant, we know that b of n behaves like a of n. So, but how do I show that b of n is greater? Because isn't that
you
what?
don't need to. That is the direct comparison.
This is limit comparison test. So because b of n diverges because it's a harmonic series of 1 over n, we know that a of n diverges. So that's what I would write.
Hey, can you see if you can take paint images?
What images? Whoa.
Like look at the images you have available.
Oh yeah. You want me to look? Okay. Let's see. What do I got? I have a bunch now. Oh, I have a very nice polar. What the? How'd you get that?
Oh, that's really cool.
How'd you do that?
There is no background, so it's just black. It's a ping. It's a ping image.
Yeah, there's.
So it's a vector diagram. It has infinite precision, basically.
That's freaking. It looks like it was drawn in here.
Look at some of the other ones.
What file type is that? Wow, that's really cool.
The axes are black. You can change the color. You'll see the axes. They change
Oh.
the background to like blue or something.
Okay. Oh. Oh yeah, it's black. Is this looks like that because yeah, so if I were to go back to the blackness and draw behind it, you can't see it, but so like you can like huh, well that's still cool. Oh. Nice. We have the golden what is that? The golden ratio. Ooh, you have this crazy thing. Dude, we should once I finish multivariable and you like hang out with me this summer, you should just do some multivariable. Yeah, I don't know what this is supposed to be. This is just a nice circle with a dot in the center. What else you got? We have some embeddedmath.com. We have a nice graph. Huh. Okay, well.
Oh yeah, there should be a log. There should be a piece of log.
What does log paper look like?
Next, there's another.
Is this log paper? What is this?
Yeah, there you go.
This is log paper?
Yeah, so okay, so you see where the lines cluster? Look at the first cluster.
Right here?
Yeah, to the left. The first one goes one. There, that cluster right there.
Oh,
At the top of that, label that one.
like at the top
Like
of
that vertical line is one. Where the last one where it clusters.
at the top? Oh, or right.
Yeah, that guy is that vertical line represents one. Then go to the next cluster.
That's 2.
10.
Oh, okay.
You go to the next cluster, that's 100. Then go to the next cluster, that's 1,000. Go to the next cluster,
It's a million.
that's 10,000.
Cool. Blows my freaking mind.
And then if you go all the way to the left, it doesn't go to 0, it goes to 110.
Oh, over here? That's nifty.
Okay, so that's one way of log paper.
I'm getting hungry.
Yeah, me too.
Should go get some yummies. Get some tacos. Okay, I'm gonna do. This guy's an alternating series. Alright, let's come over here. Put it behind me. So we have sigma n equals 0, 1. Yeah, n equals 1, infinity. So we want, no, not that one. Doing this guy. Of -1 to the n of root n over n. Okay, let me see if I remember alternating series test. Well, that's an n first off. So we have -1 to the n 1 over root n. So alternating series test. Oh, how do I want to do absolute value of a(n). Is that what alternating? Here.
Yeah, so you want to show two things. You want to show, two things. So, alright, start by writing alternating series test. Then, the first thing you want to show is that it's decreasing.
Oh.
And the second thing you want to show is that its limit is 0. Not the -1, the other part.
Limit of absolute value of a(n)? Yeah. And so yeah, it does go to 0.
Cool.
You have 1 over infinity.
And then show that it's always decreasing. So replace n by x, take its derivative, and then say that its derivative is less than 0 for all x cubed.
So you really have x to the -1/2. So you have a negative x to the -3/2. Yeah, so it's negative. So it's decreasing. So now that I know these things, I take just the limit. So it converges, right?
Wait, so that silver bullets divergence test look to the right? Oh, sorry, one down. Okay, so it's silver bullets the divergence test, right? And it's decreasing, right?
Mm-hmm.
How do you know it's decreasing?
Because it's negative. You have a negative right here. It's a negative x and negative. Yeah.
That's not really legible, but okay, right. Yeah.
So negative 1 over x.
It shouldn't be x to negative 1/2. So it doesn't make like I don't know what you're writing here. That's not really
Really?
that's not how the power rule works.
I took down the.
Oh, it's a 3/2. Oh, okay, I see. Wait.
Oh no, there should be a
And then
2.
there should be
There's a
negative
2.
1/2 in front.
Yeah,
Okay,
there's a 2. There.
that makes sense.
This is the guy.
Yeah, alright, cool.
That's lazy.
So he's less than 0. So f prime is less than 0. So right decreasing. You can say less than 0 and you can say decreasing. You should write the word decreasing. Whenever you use the opening series test, you should be like, hey, this guy's decreasing. Even if you're lying, just say he's decreasing.
Okay, so
You have nothing to back that up.
so now the actual test is what? You just take the absolute value and then do the limit. And then if it equals 0, it converges. Is that what? Oh, well, it does equal 0. Yeah, I've already done it, so cool. Moving on. Moving on to the next. Okay, so this one is just, I know, this one's easy. I'm going to skip this one because I know this one by heart. This one, okay, I'm going to do the telescoping one. See if I can recreate it and explain it in depth. So I know that this guy, we're just going to start plugging in values. So let me move away. Let me teleport to you. This is telescoping because we did this yesterday. So ln of n minus ln of n plus 1, and then sigma infinity n equals 1. So if I plug in, so you're going to have ln of 1 minus ln of 2 plus.
Can I show you another way of doing this?
Sure, since I already, pretty much know what to do. So yeah, how would I?
Look what you've got. Erase writing it out. Instead of writing it out, look what you've got. We're still going to write it out. We're only going to write out certain things.
Should I keep it in this form or?
Yeah, say sum n equals 1 to k.
Oh.
For finite unit. We call that s of k.
Okay. Okay.
S of k. So it's the partial sum.
Yeah.
So distribute the sum symbol. So you have two sums.
Like the s of k?
No,
Or
like the sigma.
oh, the sigma. Okay.
Sigma of log n minus sigma of log n plus 1.
And then minus sigma. Okay.
Now, on this second sum right?
This guy.
We're going to shift this sum. So we're going to start at 2.
Oh.
So we're going to write it, and what we're going to do on leave that. That's good.
Okay.
And then write a new one. Sum n equals 2 to k plus 1. So we'll start at 2, and we'll go to k plus 1 instead. Right?
Okay, that makes sense.
It's just going to be log of 1.
Yeah.
Right?
Yeah, that makes sense.
And then over on the left,
This guy.
that guy. Notice what happens when we plug in 1.
Yeah, you get 0.
So let's start him at 2.
Okay. So you're gonna have.
We want it to shift him. We'll just stop writing the 1 and start writing 2. The 1 just doesn't matter.
Okay, so we still have K.
Yeah.
And then we just. Oh. I'm excited.
Right. Okay. So now look at this. We're gonna write the first one exactly.
Oh, sorry, Wicket. Oh, gosh, Wicket. We need to get like a VR pet tracker.
Okay.
Okay.
So write the first one exactly the same.
Okay. All right.
So then the second one, write it with only a K on the top.
So I would do ln of
Just
ln of n.
Yeah.
But
we're missing the last term, right? We're missing what happens when n equals k plus 1, right?
yeah.
So plug in n equals k plus 1 and say plus that thing.
So
write k plus 1 to the right. Write the k plus 1 term. But you're going to have log of k plus 1.
oh,
You see what I'm saying?
like plus ln of k plus 1 in the sigma.
It's outside the sigma.
Oh, it's outside the sigma.
So
Okay.
look in front of the sigma. It's the minus sign.
This yeah.
What should happen with that minus sign?
I don't know. Should I distribute it?
Yeah, he should get a minus also because he came out of the sigma.
Okay.
So he's
That makes
just as
sense.
good as the sigma.
Filthy sigma.
So look at what we got here. So we just rewrote the sum by taking the last term off the top and writing it out of the sum.
Okay.
But now we'll get the first two sums.
Mm-hmm.
They're the same.
Yeah, they are.
So cross them off.
Oh wow.
So then we've got s sub k equals negative log of k plus 1. And then we can say the limit as k goes to infinity of s sub k
Equals negative infinity.
Yeah.
So it diverges. Hey, that's cool. Okay, let me just run it through one more time for reinforcement. Okay.
So this is how you can use the sigma notation to do the equivalent of that.
So we started here. Yeah, so then we split it up and said s of k equals this. And then, yeah, we split this up into two sigmas.
Yeah, we realized we could make minor adjustments to the...
Yeah, and then we did k plus 1. And so that gets rid of the plus 1.
It shifts the ends on the inside. Like,
Shifts over to the left, yeah. Okay, yeah, so if we start at 2, we add 1 to the top. Shift over to the left.
And as the left sum, we just noted that we didn't have to write element.
Yeah, because we don't care.
Started at 2 instead.
Yeah, we won't do anything. So this guy's cool. So we took out that plus 1, or that k plus 1. So when we take that out, we just leave it at k. Okay, yeah, because if we shift it over 1 as compared to this guy over here is n equals 1. Since this is n equals 2, we shift it over to the left by 1. And then that's how we get the minus ln of k plus 1.
We're not shifting, we're just pulling 1 off the top.
Mm-hmm.
We're taking the last term in the sum and writing it out instead.
Yeah, then they annihilate, and then you get s of k equals n negative. Man, I want to find another telescoping one, because that'd be really good to practice. Oh, my back. But yeah, that's
Yeah, the prototypical one is the sum of like 2 over n times n plus 2.
okay. sum of
But take a look at my graphic. Load some of the other graphics.
yeah. Let's see. Whoa, this one's pretty nifty. I'm in like Tron mathematics. You could do a gnarly, dude. You could do, instead of tic tac toe, why don't we do an insane game of tic tac toe where you have to like get 1, 2, 3, 4, 5, 6, 7, 8, 9. You have to get 10 in a row. Well, it's a 10 by 10, so it'd take 100, 50 turns. Extreme tic tac toe in VR. Yeah, what else we got? We have, what is this? A flight computer? Oh, a really badass. Why is there an airplane? Okay. Okay, so we're gonna do like sign of west. Okay.
What has the degrees also?
Yeah, that is a good one. Oh, I closed it. So, be gone, plane. What is this black void?
Some of the penguins who come from Alpha. I don't know what's happening. Look at the bottom row, third one. Over. Oh, that's not it. Go to the second page.
This is a worksheet. That's a worksheet. That's a logic flow. Yeah, that's all I got. Oh, are people still watching our stream?
Oh, it's wrong. A lot of the penguins.
Okay, I'm about to blow your frickin' mind. This is the best. Okay, watch this. I just made a sphere, a hollow sphere. Hey, that's kind of cool. Oh, of the stream? One time, like, wait, where's the. I got like a chair. I like stood up and I was like, I can paint up here. Like, as long as the cameras can see you, you could go vertical. I was like, I'm gonna paint the ceiling. So I tried to paint like the entire like walls of the room. So I'd look up and I was just in a box that I painted. Do you want to get food?
Yeah.
Okay, let's get food. So all you gotta do is, all right. If there's anybody watching this. Goodbye, internet.
Oh, there were two people. Did it say who the other person was? No, just two watching. Yeah, so like when you go to like video manager, it like makes videos of those things. guess you can go back and edit videos.
And it doesn't start on my computer, right? It starts
On YouTube. Oh yeah, enable DVR. Viewers will be able to seek back 4 hours while you're streaming. Make archive unlisted and complete, so you have them just disappear. Yeah. So you can like just stream it and then go back and edit the videos into like shorter videos, like problem by problem.
Oh, that's exhausting. It's hard work.
So did you get any new sweet games?
Oh yeah, if you wanna like before we go, if you wanna look at this guy. This guy's actually pretty.
Out of the ammo?
Yeah. If you wanna see. How does this? Oh, I have to enable VR.
Let's go eat.
Yeah, let's go eat first.
Okay.